Hello friends, at last we are seeing group and electronic configuration. Now let us see period and electronic configuration. In modern periodic table, electrons are filled in same cell while going along period from left to right. Let us see here from left to right. First, that is the first period, hydrogen and also the helium. Next, that is second period, lithium. Start from lithium that having electronic configuration that 2 1. Hence, from we are going left to right, the electrons are get added to the same cell. Let us see the example of the second period. In second period, that lithium having two shells and electronic configuration that is 2 1. Next to that, up to neon. Neon having electronic configuration 2 8, and these neon also having two shells. From left to right, that is lithium to neon, we can see here there are same cell, that is the two shells are present, and also the condition in third period. Third period is start from Na and that is last argon. All the electrons are added in the third shell. So the number of the valency electron and the number of shell, let us see here. In the second period, we can see that the lithium 2 1, beryllium 2 2 electronic configuration, and at the last neon having 2 8. Hence, the all having shell number is same, but the valency electrons are different. And also the condition of the third period you can see here, that also having the three shells from sodium to argon. We can see here all elements having the electronic configuration in the three shells, but let us see in the orange color they are given us the valency electron, Na having 1, Mg having 2, Al having 3, Si having 4, phosphorus also 3, then sulfur 2, chlorine 1, and here is the completion of the octet in organ we can see here. By this, we can find out that while going from left to right, within period, atomic number increase by 1. Let us see the lithium atomic number 3, beryllium 4, boron 5, then carbon 6, and up to neon, we can see that the one electron is get added and atomic number is also increased by 1. Hence, we can say that the elements with same number of shell occupied by electrons belonging same period. The elements in second period, that namely lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, have electron in two shells. That two shells are K and that is the L shell. The elements in the third period, you can see here the elements in third period that are Na, Mg, Al, Si, P, S, Cl and Ar, that are the symbols, and these are having the three shells, that shell K, shell L and shell M. Hence, by writing the electronic configuration, we are confirm that. Let us see here, they are given us also the electronic configuration. You can also see the table in our book, that is 2.8. In that also they are given us the electronic configuration, and by this we can say that the electronic configuration and also the number of shells. So, in the modern periodic table, electrons are filled in same shell while going along period in left to right, and at beginning of the next period a new shell or new electron shell starts fill up. Let us see here the second period end by the neon, and here is octet is completed, and hence the next to that there is a sodium neon having the electronic configuration that is 28 and atomic number 10, but the sodium having atomic number 11, hence one electron is get here added to the third shell. The number of elements in the first three periods are determined by electronic capacity of the shell and the law of electron octet. So, what is that law of electron octet? That atom tends to gain, lose, share electrons in order to acquire a full set of valency electron, that is to acquire the octet or duplet. Hence, that in the outermost shell they are needed 2 electrons, that is completing the duplet, or that also having 8 electrons to complete the octet, and this is by gaining or losing the electrons or also by sharing the electrons. Hence, let us see the electron shells. There are 4 shells are given here. First shell, that is K shell, second L shell, third M shell, and fourth, that is the N shell. Let us see the electron capacity of these the electron shells. Look at the table number 2.9 in our book. They are given us the shell name in the first column, that is K, L, M, N. Then the number of shell, that is K is first shell, L is second, M is third, and N is fourth. Then they are given us a formula for the capacity of electron. That formula is 2n square, and here n is the shell number. So we can fill the shell number here and find out the electron capacity. Let us see the first shell, that is K shell, having the electron capacity 2. Then the L shell, that is the second shell, having electron capacity 8. Then the third shell, that is the M shell, having electron capacity 18, and the fourth shell, that is the N shell, having electron capacity 32. Hence, here is we can see the electron capacity of the shells also. For the chemical reactivity of an element is determined by the number of valency electron in it and the shell number of the valency shell. So, this is the important information for finding out the valency electron, and also in the modern periodic table that is useful for the study of the elements.